Hi everybody, we're going to talk about some triangle similarity here. So we have three different similarity conditions. We have angle-angle similarity, we have side-angle-side similarity, and side-side-side similarity. The first one, again, there's a bunch of different scenarios that they can look like, but I want to give you just one of them. And so we're given the fact that we have parallel lines, and we need to see how our angles, if we have angles that are congruent, therefore we can have similar triangles. And so the big thing for angles is we need angles to be the same. And so we have some good information here. The first thing is that we know these two middle angles, angle BCA and angle ECD, angle 1 and angle 2, are congruent because of vertical angles. And then we know that angle A and angle D are congruent, so angle 3 and angle 4. And this is because of alternate interior angles. So I do have parallel lines, I have that transversal, and they're on opposite sides of that transversal. So they are also congruent. So just by this, we know that these triangles are similar by angle-angle similarity. Some might say, well, obviously B and E are also congruent. They are, but I don't necessarily need that. I could have done that second, but I don't need to. And since anytime I have two angles that are congruent, I have similar triangles, I can stop right there. The second one, side angle side similarity. So I'm going to draw a shape here, and again, kind of looks similar, this nice little bow tie looking thing. And I'm going to give us some sides. And so I have this right here. And I'll name my triangle X, Y, Z, W, and V. So when we try to prove if triangles are similar, oftentimes we use what's called a flow chart. And so I'm going to try to make a flow chart. I need 3 bits of information, I think, because I'm going to try to do this side angle side. I'm going to put it in the form of S, A, S, so side, angle, side. And so my first thing I'm going to show here is that 8 over 4, this equals 2. So that's the ratio of the big one to the small one is 2. I then see the fact that my angles are congruent. I have angle 1 and angle 2 here. Those are vertical angles. And so I'm going to write angle XZY is congruent to angle VZW. And you might say, like, why did I label them specifically in that order? Well, I did XZY to name that angle and to make sure that the vertex of the angle I'm talking about is that middle letter. The other two don't really matter in this case, but then the next one, I want to make sure that I'm lining up my angles correctly. So notice that X goes through that 4, and this side 8 matches up with that side 4 with the ratio. And so then I go from V to Z to make sure I keep that same relation. Finally, I have that 12 over 6, and this equals 2. And this is all good news. If these two ratios were not the same thing, then these triangles would not be similar. However, they are, so that's good news. But I also want to give some reasons, right? This 8 and 4, these were given to me. The 12 and 6, these were given to me. But the angles were not given to me. I knew this because of vertical angles, that I knew that to be true. So sometimes, again, it's a pretty good habit to put why we know these things from our bubbles. So then we go and we can finally make a conclusion. And our triangle similarities condition here is that triangle XZY is similar to triangle VZW. And again, notice this similarity symbol, just like a one nice little squiggle. And we know this by side angle side similarity. So again, I could have done that up top too, just kind of saving some time here to go through. But that's what a flow chart looks like for this chapter. And then finally, we have side-side-side similarity. So here I'm just going to draw 2 separate triangles. I have 5, 8, and 4. And I have a bigger triangle that is 15, 24, and 12. And so I notice that all my ratios are equal to 3. So I have 15 over 5 equals 3, 24 over 8 equals 3, and then 12 over 4 also equals 3. And so since all of these check out that they are the same ratio, then my triangles are similar by side, side, side similarity. So again, we have these 3 similarity conditions here to kind of go through. And I want to show one more thing, actually. So let's say that I prove in this angle-angle similarity question that I prove that the triangles are similar, and I have a side length of 2, and then x, and then a side length of, let's go 3 and 7. 3 and 7. So I can actually make a proportion now to solve for x. So I'm going to go 2 over x, and this equals, I'm going to stay on the left side, 3 over 7. So again, you kind of see how I line these sides up. And since I know that these triangles are similar, I know that this equal sign is actually true. The ratios hold. And again, we kind of looked at that with the ratios over here since they were the same. And so here I can now cross multiply, and I have 3x equals 14. I divide by 3, I divide by 3. Well, I noticed that 15 divided by 3 would give me 5, and I'm 1 short of that. So I believe that x equals 4 2/3, or 4.67 for that. And so again, that's a way that we can solve for x if we have a missing side, if we know that we have similar triangles. If we know we have similar triangles. Well, I hope that helped, everybody. Thank you.